In the previous two class, we have already discussed few topics about chemical bonding, that is ionic bond, covalent bond. Now the rest part of this chapter today we will discuss with you. तो आज हम लोग कुछ कंपाउंड्स के लुईस डॉट स्ट्रक्चर बोर्ड पर दिखाएंगे। तो चलिए स्टार्ट करते हैं। फर्स्ट कंपाउंड लेट अस टेक H2SO4, that means sulfuric acid. So what will be the Lewis dot structure of sulfuric acid? So here central atom equal to sulfur, which has total 6 valence electrons. Let us notice here we make a table where the group are 1 to 17 and the valence electrons of the respective group elements are given below. For example, in group 1 like lithium, sodium, potassium, rubidium, cesium all have 1 valence electron. Similarly in group 2 these elements have 2 valence electrons. Similarly in group 13 boron, aluminium, helium, indium, thallium have group 13 element and 3 valence electron and so on. So from this table we can see that sulfur is the element of group 16, so have valence electron equal to 6. So central atom sulfur valence electrons equal to 6. Now draw the structure how sulfur makes bonds with oxygen or hydrogen. So here sulfur here makes O bond. Similarly, O here this is actually the Lewis dot diagram of sulfur, where cross symbol means bond pair of electrons and dot means lone pair of electrons. So these are actually the bond pair of electrons and these are the lone pair of electrons which does not remain in bond formation. So the equivalent structure of H2SO4 will be S single bond O single bond H. Similarly here single bond O single bond H. Here double bond O. There also double bond O. This one. Here notice that around central atom sulfur total 12 electron present. So here sulfur has 12 electrons surrounding itself. That means the octet rule is not valid here, because sulfur is the third period element have vacant d orbital. As a result, sulfur has the ability to accommodate more than 8 electrons in their valence shell. So this is the Lewis dot structure for H2SO4, where sulfur is the central atom, 2 oxygens are double bonded and 2 oxygens are single covalent bonded with sulfur. Okay. Let's take another example. Let us take another example of the compound HNO3, that is nitric acid. HNO nitric acid. What will be the Lewis dot structure for nitric acid? So here similarly the central atom equal to nitrogen. And from this table you can see that nitrogen is the element of group 15 with 5 valence electrons. So valence electrons of nitrogen equal to 5. So now let us draw the structure. So nitrogen makes a bond with oxygen, this one, another bond with oxygen, this one, and this. Now in that case, the total electrons around nitrogen 1, 2, 3, 4, 5, 6, and also 2 electrons available now in nitrogen. So here another oxygen is present like this, and these 2 electrons remaining on nitrogen is co-ordinate bond makes with oxygen. So here this electron pair present in nitrogen atom makes a coordinate bond with oxygen. Here double bond is not formed because nitrogen is second period element and doesn't have any vacancy orbital. So nitrogen doesn't have any ability to expand its octet, that is to gain more than 8 electron in the valence shell. So this is a coordinate bond where electron pair sharing is take place unequally, that is between this bond only nitrogen donates its electron pair and oxygen accepts this electron pair to make this bond. So this is called co-ordinate bond. Co-ordinate bond. So here a coordinate bond is formed, and let the equivalent structure will be N double bond O, single bond O, H with a coordinate bond formation. So this is the Lewis dot structure for nitric acid. Here a coordinate bond is formed between nitrogen and oxygen. So let us check. So this is the Lewis dot structure of HNO3. Now we are studying another topic of this chapter, that is called formal charge. So now we are going to study formal charge. Okay. So what is formal charge? Now it is defined as the amount of charge left in an individual atom after the formation of a covalent bond. So what is formal charge? Now it is the amount of charge left in an atom when this atom makes a covalent bond with another atoms. So how can we calculate formal charge? Now there is a formula to calculate formal charge, that is Fc equal to Ve, that is total number of valence electron in free atom, minus Le, that is the total number of lone pair of electron present after the covalent bond formation, minus Be by 2, where Be is the total number of bond pair of electrons. So in this formula 3 terms are there. One is Ve, that is Ve equal to total number of valence electrons in free atom. Le equal to total number of lone pair of electrons, total number of lone pair of electrons, and another term Be equal to total number of bond pair of electrons. So by using this simple formula we can calculate the formal charge on a particular atom for a particular structure. Let us take an example. Ozone. This is the molecule of ozone. This is the molecular formula of ozone, and ozone has the molecular structure like O, double bond O, single bond. Now there is 3 oxygen atom in ozone covalently bonded like that. Now we will take the number, this oxygen 1, this is 2, this is 3. Now we can calculate what is the formal charge in this oxygen atom or this oxygen atom or this oxygen atom individually. So let us take first formal charge on oxygen 1, that is in this oxygen what is the formal charge. To calculate this we can take formal charge on O1 in number 1 oxygen atom. The formula is valence electron. So total number of valence electron in oxygen is 6 minus number of lone pair of electrons. So in that oxygen there is total 1, 2, 3, 4, 5, 6. 6 lone pair of electrons. So 6 minus bond pair of electrons by 2. So in oxygen there is a 1 covalent bond and 1 bond equal to 2 electrons. So there will be total bond pair of electrons 2 by 2. That is equal to 6 minus 6 minus 1, that is equal to minus 1. So the formal charge on this oxygen atom is minus 1. Clear? Now we can calculate what is the formal charge on this oxygen atom. So formal charge on oxygen number 2 equal to 6 valence electron minus number of lone pair in this oxygen atom is 2. So 2 minus total number of bond pair 1, 2, 3, total 3 bonds, so 6 electrons, so 6 by 2, that will equal to give you the plus 1. So the formal charge on this oxygen atom is plus 1. Now in this oxygen atom, what will be the formal charge? So Hc on O3, that is in third oxygen atom, equal to similarly 6 minus total number of lone pair of electrons equal to 1, 2, 3, 4. So there is total 4 lone pair of electrons. So minus 4 minus total number of bond pair of electrons, 2 bond equal to 4 electrons. So 4 minus 2, that will equal to 0. That means there is no charge in this oxygen atom. So by this way, for a given structure, you can calculate the formal charge of an individual atom. The formula is this. Please note. Now, here, now let us take another example. Now, let us take another example to calculate the formal charge. Another example we take NO3 minus, and the structure of NO3 minus is N double bond O, single bond O, single bond O. There is 4 lone pair, there is total 6 lone pair, and in this oxygen also have 6 lone pairs. So there is total 4 atom, 3 oxygen atom and 1 nitrogen atom. Now we calculate individually what are the formal charge on 3 oxygen atom and on nitrogen atom. So for this we can take a number for this oxygen 1, this oxygen 2 and this oxygen 3. Now here we can first try to calculate the formal charge in this oxygen atom, that means in first oxygen atom. So similarly, like previous example, total number of valence electron equal to 6 minus total number of lone pair equal to 2, 4, 6 minus total number of bond pairs by 2, that will give you minus 1. Similarly, on oxygen 2, So oxygen has valence electron equal to 6 minus total number of lone pair here 4 minus total number of bond pair also here 4. So 4 by 2, that will give you 0. So this oxygen has neither any positive charge nor negative charge. Now in third oxygen, similarly it will be 6 minus 2 by 2 equal to 6 total number of valence electron minus total lone pair of electron 6 minus bond pair of electron by 2, that will equal to minus 1. So this oxygen atom has minus 1 negative charge, this oxygen atom also has minus 1 negative charge, and this oxygen atom has neither any positive nor negative charge. Now let us the nitrogen. For nitrogen, formal charge on nitrogen atom equal to total number of valence electron in nitrogen is 5. So 5 minus, there is no lone pair of electrons, so it will be 0 minus total number of bond pair of electrons here for nitrogen is 2, 4, 6, 8. That means 4 bonds, so 8 electrons. So 8 by 2, that will give you plus 1. That means nitrogen atom is positively charged here. Now let us see. There is this oxygen is minus 1, this oxygen is minus 1, and this is plus 1. But in the formula there is NO3 minus. That means the one negative charge and one positive charge cancel out with each other and give a particular one minus charge for all the nitride ion. So this is the Lewis dot. So this is the way how to calculate formal charge for a particular atom in a molecule. Now this is, now let us go into another topic. Now we have take limitation of Octet rule. Limitation of Octet rule. So in the previous class we have discussed that all the elements in the periodic table try to attain 8 electron in their valence shell so that they get the stable noble gas electronic configuration, and for that reason they are take part in chemical bonding, covalent bonding, ionic bonding. Now we can see few examples or few compounds where octet rule is not valid. That means in that cases the central atom either have more than 8 electrons or less than 8 electrons. So there are two possibilities. One is when central atom has less than 8 electrons. This situation is called incomplete octet. Incomplete octet. So in that situation what happens? In this incomplete octet, in this case central atom has less than 8 electrons. This is less than, मतलब here क्या होता है? In that case incomplete octet में central atom के पास 8 इलेक्ट्रॉन से कम इलेक्ट्रॉन होती है. For example, halides of group 13 elements. Halides of group 13 elements. You can see here these are the elements of group 13, that is boron, aluminium, gallium, indium and therium. These are all elements of group 13 and they form halides with incomplete octet. For example, BCl3 or AlCl3, because in that case the central atom has only 3 valence electrons, so they are able to form only 3 covalent bonds with maximum of 6 electrons. Let us see the structure of BCl3. The structure of BCl3 is like that, Cl, Cl, Cl. So here surrounding boron there is total 3 covalent bonds, means 6 electrons. So the octet rule is not valid here, क्योंकि here central atom has only 6 electrons, that is less than octet. Clear? So this is the incomplete octet. And another case for limitation of octet rule is that expandable octet. In such situation, the central atom has more than 8 electrons. Let us take the example. We can see the expanded octet. Expanded octet. In that case, what happens? In that case, central atom has more than 8 electrons. This is more than. तो in that situation क्या होता है? Central atom के पास more than 8 electrons होता है. For example, halides of group 15, 16 and 17 elements. So the group 15, 16 or 17 elements, that means nitrogen, phosphorus, arsenic, antimony, bismuth. But here except second period elements को छोड़ के, जैसे कि group 15 की second period elements है nitrogen. So other than nitrogen, all other, that is phosphorus, arsenic, antimony, they are capable to show expanded octet. Similarly, in group 16, other than oxygen, that is sulfur, selenium, can capable to show expanded octet. In group 17, other than fluorine, chlorine, bromine, iodine can capable to show expanded octet. Clear? So for group 15, example, group 15 elements of phosphorus, expanded octet halide PCl5. For group 16, SF6. For group 17, IH7. In all that case, in case of PCl5, the central atom phosphorus surrounding 10 electrons around itself. In SF6, the central atom sulfur surrounding 12 electrons around itself. In IH7, the central atom around iodine surrounding 14 electrons itself. Okay. So in all the halides of group 15, 16 and 17 that are taken in example like PCl5, the central atom phosphorus has 10 electrons, that is expanded octet. In case of SF6, the central atom sulfur has 12 electrons surrounding themselves, so it is also expanded octet. In case of IH7, the central atom iodine has 14 electrons, that means expanded octet. So take a diagram for, let us take the diagram of SF6. So here the diagram of SF6 geometry is like that. Yes. So here is total 1, 2, 3, 4, 5, 6 covalent bonds. So surrounding sulfur there is 12 electrons. Similarly, so these are the limitation of octet rule, where few compounds जैसे कि group 13 halides show incomplete octet and group 15, 16, 17 elements halides show expanded octet. So now let us discuss another topic, that is polarization or deformation of ions and related to valence too. Now we can going to discuss about polarization or deformation of ions, and related to this one important concept is valence rule. This is very much important for competitive exam. बहुत सारे क्वेश्चंस इस कॉन्सेप्ट से पूछा जाता है इन आईआईटी और इन मेडिकल एंट्रेंस नीट। सो अब हम लोग पोलराइजेशन और डिफॉर्मेशन ऑफ आयन क्या है इसके बारे में जानेंगे। तो जैसे कि हम पहले क्लास में डिस्कशन कर चुके हैं कि कोई भी बॉन्ड 100% आयोनिक या 100% कोवैलेंट नहीं होता है। In a ionic bond, there may be somewhat covalent character. Similarly, in a covalent bond, there may be somewhat ionic character. So, now the polarization or deformation of ions actually gives us a qualitative idea how the covalent character induces in a ionic bond, or how the ion gets deformed to form a or to increase a covalent character. So polarization is basically the deformation of ions. और इसमें क्या होता है, आयन्स डिफॉर्म्स हो जाते हैं, मतलब जो आयनिक कैरेक्टर है किसी आयनिक बॉन्ड में वो कैरेक्टर धीरे धीरे कम हो जाती है और उसके अंदर कोवैलेंट कैरेक्टर की इंड्यूशन होती है। सो डिफॉर्मेशन की वजह से क्या होता है, आयन्स गेट्स डिफॉर्म्ड, ionic character decreases or covalent character increases. Now let us take a proper diagram to understand how polarization of ions takes place. जैसे कि आप लोग जानते हैं जब कोई भी कैटायन या एनायन फ्री होते हैं, then the electron cloud of that particular cation and anions are uniformly distributed. So let us take, this is a cation with positive charge and this is an anion with negative charge. So this is the cation and this is the anion. When this cation and anions are remains free from each other, then the electron cloud of both cation and anions are uniformly distributed. But when they are came close to each other, then the positive charge density of cation will attract the negative electron cloud of anion. As a result, the uniform electron density of the anion gets deformed. So, when these are came close to each other, what happens? The uniform electron density of the anion gradually deformed. That is like this, keeping the nucleus in a same position. So इसमें क्या होता है, जो कि एनायन की नेगेटिव चार्ज डेंसिटी है that will moves towards the cation because cation attract the negative charge density of the anion, and after some time this anion completely overlap with the cation to induce a covalent character in the molecule, that is the cation and that is the anion. So here you see that in the first case, when both the cation and anions are remains free from each other, there was a real existence of individual cation and anion. But after when they are came close to each other, the electron cloud of anion gets deformed by the positive charge cation, and then slowly cation and anion both are overlapped with each other to induce somewhat covalent character in the molecule. So in that way the deformation of ion takes place, and as a result ionic to covalent character induces in a molecule. So from this concept we can see that greater the polarization, greater will be the covalent character in a ionic bond. Clear? So here we can get another important concept, that is क्या कि greater the polarized greater the polarization, greater will be the covalent character in a molecule. So we can say that greater the polarization, greater will be the covalent character in a molecule. And from this concept, a famous scientist Partha gives us a rule that how the polarization affect, or what is the factor that increases or decreases the rate of polarization. So now we can discuss factor affecting polarization of ions. Now we can discuss the factor affecting the polarization of ions. So basically the rate of polarization or the rate of deformation of ions depends on both the size of cation and anion, and also the positive charge density of cation and the negative charge of anion. So let us see. What are the factors? Number one is size of cation. Number two, charge of cation. Number three, size of anion. Number four, charge of anions. In this polarization depends. So कैसे? How the rate of polarization increase? The size of cation will be small. क्योंकि small size of cation has greater ability to deform the negative charge density or negative electron cloud density of anion. So size of cation will be small, charge of cation will be high, क्योंकि high charge of cation means high charge density means greater the tendency to polarize an anion. Similarly, size of anion large and charge of cation high. That is the favorable condition for polarization of ions. So what happens? Ki small size of cation with high charge density and large size of anion with high charge density favors the polarization, means increases the rate of polarization, and as a result greater will be the covalent character in a molecule. So it क्या होता है? As a result क्या होता है? This will gives you the more polarization. That will gives you the more polarization. That means less ionic character, less ionic character. That means more covalent character. Clear? So we can say that when an ionic bond is formed with small size of cation with high charge density and large size of anion with high charge density has greater covalent character. Clear? Let us take few examples how the ionic and covalent character changes with considering the Halides rule. Clear? So now let us take the halides of group 1 LiCl, NaCl, KCl, RbCl. So now we can take the halides. In all these, both have the cation Li plus. Here the cation is Na plus. In that case, cation is K plus, and here rubidium plus. And anions are same for all the 4 halide, and that is Cl minus. So in the given example, the anions are same, but the cations are differ in their size. Charge density of both the cations are +1, but down the group from lithium to sodium to potassium to rubidium, size of cation increases. साइज ऑफ कैटायन इंक्रीज होती है। अब कैटायन की साइज इंक्रीज होने से पोलराइजेशन लेस होती है। पोलराइजेशन लेस होती है क्योंकि स्मॉल साइज ऑफ कैटायन हैज ग्रेटर एबिलिटी टू पोलराइजेशन। सो क्या होता है, पोलराइजेशन लेस होता है। लेस पोलराइजेशन, लेस पोलराइजेशन मींस क्या, मोर आयोनिक कैरेक्टर, दैट इज लेस कोवैलेंट कैरेक्टर। लेस पोलराइजेशन मींस क्या होता है, मोर आयोनिक कैरेक्टर, मोर आयोनिक कैरेक्टर। सो ionic character of these halides will be in the order, ionic character will be in the order RbCl greater than KCl greater than NaCl greater than LiCl. So from the concepts of Pajan's rule we can predict which of the halide is more ionic or which of the halide is less ionic or more covalent. Now let us take clear. Now let us take another example of ये clear हो गया. Now let us take another example of fluoride, that is NaCl sodium chloride, NaBr sodium bromide, NaI, and another one Na. So now we can take 4 different halides of sodium. So in all the cases cations are same, that is Na plus, but here anions are different. Here anion is F minus, here anion is Cl minus, here Br minus, and here I minus. And in all the case cations are same, that is Na plus. So anions have the same charge, that is -1, but down the group from fluorine to bromine to iodine, size of anion increases. Size of anion increases as the anions size increase होती है. So large size of anion gives more polarization. So size of anion increases, so क्या होगा, more polarization. See down the group size of anion increases, as size of anion increases gives you the more polarization, और more polarization means क्या होगा, less ionic character. More polarization means हो जाएगा less ionic character or more covalent character. Clear? So here the ionic character is less for this and ionic character is more for this. Clear? Now let us take one more example. So ये हो गया halides के. Now let us take one more example, that is NaCl, MgCl2 and AlCl3. In these 3 compounds the anions are same. For NaCl it is Cl minus, in case of MgCl2 also it is Cl minus, in case of AlCl3 it is also Cl minus, but the cations are different. In NaCl the cation is Na plus, In MgCl2 cation is Mg plus 2 and AlCl3 the cation is Al plus 3. So here we can see that the charge of cation increases from this one to this one to this one. So here charge of cation क्या है, from this direction, that is from sodium to magnesium to aluminum, charge of cation increases. As the charge of cation increases, high charge of cation means more polarization. So what happens? More polarization. Clear? As the charge of cation increases, so high charge of cation means more polarization. So I am writing here more polarization. More polarization means क्या होता है? Less harmonic character. So here will be less harmonic character or more covalent character. Clear? So more polarization means क्या होगा? Less harmonic character हो जाएगा और covalent character more हो जाएगा. Clear? So by this Halides rule, by remembering these factors, we can correlate or compare the ionic character of a series of molecules. जैसे हम 3 एग्जाम्पल आप लोगों को दिखाया है. Clear? Now we can study another topic. तो ये हो गया polarization और deformation of ions. तो इसको मिटा देते हैं. So polarization of ions and Halides rule. This topic is very much important for JEE NET and NEET एग्जाम. बहुत सारे क्वेश्चंस इस कॉन्सेप्ट के ऊपर पूछा जाता है. सो आप लोग इस कॉन्सेप्ट को तैयार करें ठीक से, ताकि यहाँ से कोई भी क्वेश्चन आए उसका आंसर दे सके. Now we can discuss another important topic and another important part of this chapter, and that is hybridization. Another important part of this chapter is hybridization of central atom in a covalent molecule. In a covalent molecule. So अब हम लोग बहुत ही इम्पोर्टेंट टॉपिक, ये बोर्ड एग्जाम के लिए बहुत इम्पोर्टेंट है, क्योंकि बहुत सारे क्वेश्चंस कंपाउंड दिया जाता है और सेंट्रल एटम का हाइब्रिडाइजेशन क्या है इसके बारे में पूछा जाता है. सो नाउ वी कैन डिस्कस व्हाट इज हाइब्रिडाइजेशन एंड हाउ कैन वी डिटरमाइन द हाइब्रिडाइजेशन ऑफ द सेंट्रल एटम इन द कोवैलेंट मॉलिक्यूल. तो आप सब लोग प्रीवियस क्लास से ये जान चुके हैं कि जब कोई भी कोवैलेंट बॉन्डिंग होता है, देन देयर occurs the sharing of electron pairs between central atom and the bonded atom. Now these electrons which shared during the formation of a covalent bond comes from different atomic orbitals with different energies. As a result, the bond formed are not so much effective. So actually वहाँ क्या होता है? When the electrons are come from different atomic orbital like S, P, D, then there occurs a mixing of these orbitals prior to the bonding. मतलब bonding, chemical bonding होने से पहले उस orbitals का mixing होता है. These orbitals are mixed up with each other to give a mixing orbital with similar energy. Clear? तो हाइब्रिडाइजेशन का कुछ फैक्टर्स है, हाइब्रिडाइजेशन का कुछ साइलेंट फीचर्स है. वो क्या क्या है? हाइब्रिडाइजेशन में क्या होता है? कुछ साइलेंट फीचर है. ये नंबर ऑफ हाइब्रिड ऑर्बिटल इक्वल टू number of atomic orbital involved in overlapping. So क्या होता है कि during the hybridization the different atomic orbitals of central atom mixed with each other to make a more efficient and equalization of energies atomic orbitals. So first has the number of hybrid orbitals. जितने hybrid orbital की formation होगा that will be equal to the number of atomic orbitals involved. That means if two atomic orbitals are involved in hybridization, then the number of hybrid orbital will be 2. If 3 atomic orbitals are involved in hybridization, then number of hybrid orbital will be 3. So number 1 ये हो गया कि number of hybrid orbital involved is equal to number of atomic orbital. Next है hybrid orbitals are always same in size and energy. सेकेंड है कि जो हाइब्रिड ऑर्बिटल की फॉर्मेशन होगी दे ऑल आर सेम इन साइज एंड इक्वल इन एनर्जी. मतलब सारे ऑर्बिटल्स का साइज सेम होगा एंड दे ऑल हैव द सिमिलर एनर्जी. क्लियर. नंबर 3 दे आर मोर एफिशिएंट than atomic orbital. Clear. थर्ड वन कि जो हाइब्रिड ऑर्बिटल्स फॉर्मेशन होती है by the mixing of more than one atomic orbitals. These hybrid orbitals are more efficient in bonding formation than the individual atomic orbitals. And number 4, these hybrid orbitals are oriented in a space in such a direction so that the bond pair repulsion becomes minimum. तो क्या होता है? They are directed in space to minimize the bond pair repulsion. Yeah. So after the formation of hybrid orbitals, they are oriented in space in such a way that the bond pair repulsion becomes minimum. So these are the silent features of hybridization. कि hybridization क्या है, कैसे होती है. Now we can see what are the type of hybridizations and how the hybrid orbitals are formed with taking proper example of covalent compounds. So note here, please take a look about the silent features of hybridizations. Number of hybrid orbitals equal to number of atomic orbitals. Hybrid orbitals are always same in size and energy, more efficient than atomic orbitals, and directed in space to minimize the bond pair repulsion. To minimize the bond pair repulsion. Now we can see what are the type of hybridizations. Now अब हम लोग देखते हैं टाइप ऑफ हाइब्रिडाइजेशन के बारे में कि हाइब्रिडाइजेशन का टाइप क्या क्या होता है. हाइब्रिडाइजेशन का टाइप क्या होता है. तो इसीलिए हम एक टेबल बनाते हैं या नंबर ऑफ atomic orbital, number of atomic orbitals involved in hybridization. So first column is for number of atomic orbitals involved in hybridization. Clear. Second, hybridization क्या होगा. Hybridization number of hybrid orbital. Actually hybridization depends on the number of atomic orbitals. By knowing the number of atomic orbitals involved, we can easily predict what will be the hybridization with few common concepts. Hybridization. Next, name of hybrid orbitals, name of hybrid orbitals involved. अब हम देखें इस कॉलम में कि कौन कौन सी हाइब्रिड ऑर्बिटल दिस पर्टिकुलर हाइब्रिडाइजेशन के लिए इन्वॉल्व है. सो नेम ऑफ द हाइब्रिड ऑर्बिटल्स, नेम ऑफ हाइब्रिड ऑर्बिटल्स इन्वॉल्व. नेक्स्ट, स्पेशल अरेंजमेंट. Special arrangement, that means they are bonding in क्या होगा. ये सारे हम लोग देखेंगे कि टाइप में एक टेबल के माध्यम से हम लोग ये देखेंगे कि नंबर ऑफ एटॉमिक ऑर्बिटल्स के हिसाब से हाइब्रिडाइजेशन क्या होती है, उसमें कौन कौन से हाइब्रिड ऑर्बिटल्स, कौन कौन से एटॉमिक ऑर्बिटल्स. नेम ऑफ एटॉमिक ऑर्बिटल्स, नॉट हाइब्रिड, सॉरी, दिस इज नॉट हाइब्रिड ऑर्बिटल, दिस इज एटॉमिक. नंबर ऑफ एटॉम्स, कौन कौन सी एटॉमिक ऑर्बिटल उस पर्टिकुलर हाइब्रिडाइजेशन के लिए इन्वॉल्व है, एंड फॉर दिस हाइब्रिडाइजेशन स्पेशल अरेंजमेंट क्या है. सो फर्स्ट, नंबर ऑफ एटॉमिक ऑर्बिटल 2. इफ देयर आर 2 एटॉमिक ऑर्बिटल्स involved in the hybridization, then it will give you sp hybridization, means one s orbital and one p orbital, that is one s orbital and one p, ये s और p, one s orbital and one p orbital overlap with each other to give sp. So name of the hybrid orbital, atomic orbitals involved s plus p. p की 3 orbitals होते हैं, जैसे कि आप लोग जानते हैं कि देयर इज टोटल 3 p orbital, that is px, py and pz. Among these 3, any one of the p orbital involved. So 1 s and 1 p. Special arrangement होगा 180 degree with linear geometry. Clear? Now number of atomic orbital 3, तो hybridization हो जाएगा sp2. That means 1s and 2p orbitals combined, so sp2. That will here क्या होगा, s plus any of the 2p orbitals. So let us write px and we think that px and py. But there may be s plus px plus pz or s plus py plus pz. That is any 2p orbital among 3. Here special arrangement is 120 degree with trigonal planar geometry. 4. नंबर 4 के लिए एक हाइब्रिडाइजेशन हो सकता है sp3 with s plus px plus py plus pz with special arrangement of 109 degree 28 degree टेट्राहेड्रल ज्योमेट्री के साथ. और इसके लिए और एक होता है, that is dsp2 hybridization. The one d, that d is actually dx square minus y square plus s plus px plus or py, any 2p orbital. Here bond angles are 90 degrees. Here अब है 5 तो हो जाएगा sp3d with s plus px plus or py plus or pj, and the d orbital involved here is dz square. And here 3 bond angles are available, sp3d 180 degree, 90 degree and 120 degrees. Clear? 180 degree, 90 degree and 20 degree. Clear? And this is actually give you linear geometry. This is trigonal planar geometry. This is tetrahedral geometry. This will give you square planar geometry. This will give you ट्राइगोनल बाइपिरामिडल ज्योमेट्री। अनदर वन 6, तो हो जाएगा sp3d2 और d2sp3, जहाँ s प्लस px प्लस py प्लस pj 3p orbitals along with 2d orbital, that is dx square minus y square plus of dz square। क्लियर? तो यहाँ हो जाएगा बॉन्ड एंगल 90 डिग्री एंड 180 डिग्री विथ ज्योमेट्री octahedral। And another one, if there is 7, so it will be sp3d3 hybridization with s plus px plus py plus pj plus dxy plus dxj plus dyz with pentagonal bipyramidal geometry। pentagonal bipyramidal। Clear? So let's have a look in the table। हमने एक टेबल बनाई है जिसमें नंबर ऑफ एटॉमिक ऑर्बिटल्स कितने हैं और उसके दैट रेस्पेक्ट टू गिव व्हाट विल बी द हाइब्रिडाइजेशन। ये है दिस पर्टिकुलर हाइब्रिडाइजेशन के लिए कौन कौन से एटॉमिक ऑर्बिटल इन्वॉल्व है, ये इस कॉलम में है, और उस पर्टिकुलर हाइब्रिडाइजेशन की ज्योमेट्री एंड बॉन्ड एंगल्स क्या है जो यहाँ पर दिया गया है। सो फॉर 2 atomic orbitals hybridization will be sp, for 3 it will be sp2, for 4 sp3 dsp2 and that one। So take a look in that table। तो ये हो गया हाइब्रिडाइजेशन के एक टेबल। तो ठीक है, आज के लिए इतना ही। माई सेल्फ पार्थ तंतुबोय फ्रॉम श्री झारखंड क्लास 2 हाई स्कूल तारा जमुआ। तो ये आप इस चैप्टर को सही से तैयार कीजिए इस एपिसोड को, और इस चैप्टर की जो आगे का कंटेंट है वो हम लोग अगले क्लास में डिस्कस करेंगे। सो आज के लिए थैंक यू।